Okay, so continuing on with example 1, we're going to have y equals x squared, obviously a very famous looking parabola. And we're going to go from x equals 1 to x equals 5, but with 8 rectangles, we can determine that delta x, the base of a rectangle, is b minus a over n. So it's 5 minus 1, all over 8. 4 over 8 is just a half. Now, I guess just for starters, I think I am going to real quickly draw out a nice little picture here. So we'd have 1, and here's 1.5, here's 2, here's 2.5, here's 3, here's 3.5, and we've got 4, 4.5, and we have 5. And you could see the 8 rectangles taking shape. So let's just say that we've got this widespread parabola, and it looks something like that. Forgive the sloppiness. You know what y equals x squared looks like. But what's happening is they're saying, could you do an LRAM? What I strongly suggest that you do is you make yourself a first rectangle and a last rectangle. That can be so helpful. Look, we know if we're going with 8 rectangles, and you can see all the bases there, if I'm doing LRAM, it's the left endpoint that determines my height. So my first rectangle occurs from x equals 1 to x equals 1.5, but the x value on the left actually is determining how tall that rectangle is. Similarly, if my last x value on the interval is 5, but my base of my rectangle is a half, 5 minus a half is 4.5. In a very similar format, you could say, well, that means my height here is going to be determined by 4.5. So I guess what I want to show you also is that when it comes to calculating the area, you have two extremes. You could work this out by hand, saying I'm going to determine all 8 rectangle areas, determine all those heights, plug everything into the calculator and really plow through it. But my word, that is painstakingly a lot of work. I'd like to show you that there was this wonderful tool with Sigma, and we are going to let the calculator come to our rescue here. There is a format that we're always going to use for at least this section today. We'll use sum, sequence. We'll have our expression for area, really. What's the formula for area? We'll have x. We'll have a starting x value, the starting x value that determines your first height. When I say start, I mean it's the x value that will determine your first height. The ending x value, of course, is going to be your final x value used to determine a height. And then you're going to type in something called a step. So I guess what I'm trying to point out to you is right now, if I were to write this out, if I were to try to get this going, you could say, well, let's see, we could say sum sequence. We'll do sum sequence. And you can think, what on earth is our area expression? Well, the area expression is going to be your height times your base. It's your height times your base. And you might think, well, where's that coming from? Well, it's coming from right here. It's your function value times delta x. The function value times delta x, always. So we're going to come here and we'll say, well, my function value is x squared. That's my height. What's my base in this problem? Well, the base is 1/2. Kids might say, where'd that come from? Right over here. That's your delta x, right? Then I need my starting x value. what x value was used to start us off with our first height? X equaled 1. That's right here. What's my last x value for a height? 4.5. And guess what your step is? 0.5. Your step is always delta x. Your step is always delta x. The area expression will always be f of x times delta x. That's how you find the area of a rectangle. The f of x is your height. Delta x is your base. Delta x shows up twice. Well, right now, guys, the big question is, how do we type this out? Well, you all have a graphing calculator, and I'd like to right now walk you through how we can do this. So all you got to do is to get sum and sequence to show up. Now, a wonderful tool that you have is your catalog button. If you look at the very bottom of the 0 button, right above it is catalog. I'm going to hit second catalog. And when you hit second 0, you get catalog. You can think, well, every feature on the calculator should be here. I'm next going to press the letter S because I want to get to sum. That's LN. If you look where the LN button is, you can see in the top right corner of your calculator screen, it's got the letter A in there. So it's standing for the alphabet. Ironically, when you hit S, you see 2 sample tests. You see the number 2 first. It won't take you too long, though, if you scroll down to get sum. You can get there pretty fast. I'm sure you guys will get there quicker than me. Okay, and it's coming up pretty soon. I think it's right here. So we'll hit sum. Then I'm going to go back to catalog. Second catalog. I'll hit S again. Sequence is not quite as far. It's right here. You need the sequence with the parenthesis. If you down arrow, there's one without it. You want the sequence with that parenthesis. Then what? You type in your expression. You'll hit x squared times a half. How about we just go times 0.5? Now I'll say comma. That's right above the 7. My starting x value is 1. My ending x value is 4.5. And here I go with a t step, increasing my x value of 0.5. When I hit enter, oops, what just happened? Let's see here. Just did something wrong. Oh, it was x squared times 0.5 comma x. Oh my gosh. So sorry, guys. You can see I did that right here. I forgot my x. Sorry about that. We just got to fix that up a little bit. I wrote it right here and I forgot it. Yeah, it gets a little bit persnickety in terms of saying an x. Let's make sure that then we have our starting x value of 1. Then we'll go to 4.5. And then we'll say comma 0.5. Sorry about that. Hit enter and you'll get 35.5. That's your area calculated by LRAM. Okay? What you've just done is you've told the calculator to say, look, I need you to do a base times a height and then add up another base times a height and then add up yet another base times a height. Keep doing that over and over and over again. Start with x equals 1. That's the first type of a problem that we're going to be working with. End with x equals 4.5. That's the last time I'm going to need a height. Each time we move from one x to the another, increase by 0.5. And that's all you have to do to calculate an LRAM. Okay? Yeah.
Can you go over how you got those first two numbers?
The 1, the x squared and the 1/2. X squared is this right here. It's the y value that you have. It's the y value that you're going to be calculating. The 1/2 is always the base of your rectangle, right? So every time you have a height, Daniel, you're going to have essentially a vertical segment. A vertical segment is a y segment, and the y segment is f of x. Okay? So as we move over to RRAM, I hope you're going to see that RRAM looks amazingly close, except you still have the same base for your first rectangle and your last rectangle. But my goodness, as you look right now, you're going to see very quickly that the endpoints are different to determine your height. It's the right endpoint. So very quickly, someone could say, well, that means my sum and my sequence. Well, Daniel is just asking, where's the x squared and this 1/2 coming from? It's your height times your base. It's always your f of x. The base is always your delta x. So I'm going to maybe just type in a 1/2 or 0.5. Then you're going to need an x. That's what I forgot earlier. Always got to have that. Then, what's my first x value used to determine a height now? 1.5. It's no longer a 1. The first x value I'm using is 1.5. What's the ending x value I'm using? Just a 5. You can see that the last thing I'm going to use is just that. You're always going to end with delta x. You're always ending with 1/2. Now, here's the cool news. Right now, you can think, oh gosh, I got to retype all that. Actually, no, you don't. Hit second enter, and what you just typed in will come back. And you can left scroll, you can left arrow, and you can see here's your f of x times delta x, x squared times 0.5. You'll need a comma x. Then you will have a 1.5. This is where I'm going to change it. I'm going to go 1.5 instead of 1. Now I'll type comma. The ending is just a 5. And then I'll say comma 0.5 to finish. Okay, we doing okay? Hit enter, and you get 47.5. Hey, that's bigger. Should we be surprised that we got a bigger number right now? No, if you look at those red rectangles, they're going over the curve. I'm getting more area, right? So there's one last thing to do. You can think, well, now wait a minute, how do we wrap up here? Well, that's with MRAM. Now with MRAM, you're just going to have the same beginning and ending bases, but now you're going to say, now wait a minute, I need midpoints. What's the midpoint between 1 and 1.5? 1.25. And what's the midpoint between 4.5 and 5? 4.75. And you could say, well, no, wait a minute. In green, if we made our rectangle like so, and here you might see it a little bit clearer, you can see part of your rectangle's above the curve, part of it's below. The only thing that's going to be different with an MRAM is that you're going to have different starts and ends. You still have your function times delta x. That's still there. You're still going to have an x, but what's my starting x value now? 1.25. What's my ending? 4.75. And you still have a 1/2 to wrap it up. So now you just go back to your calculator, and you can say second enter, and you're just going to make a few changes. Everything's the same except your beginning x now is 1.25, comma. Your ending x is 4.75. And you could say my step, my delta x, is 0.5. So we could real quickly hit enter, and you get something in between, 41.25. Notice 41.25 is not the average of LRAM and RRAM. It's close, but it's